Okay, so in this video I'm going to have a look at questions involving logs. So I'm going to look at two questions in particular, and this is the first one here. This one involves this equation here: Q is equal to AE to the power of BT, where Q is a quantity of material that we would have. We're looking at radioactive material, by the way, so the radioactive material will decay over time. So what's the quantity then at any particular time? T. T is our time in days, and A and B are both constants, which we're going to work out in part 1. The other bit of information that we're going to be given is that we're going to start with 30 grams, and also that after 8 days we're going to only have 15 grams left because the material is decaying over time. So our first question here involves finding A and B. This A here and this B here are both constants. We don't know what they are. They're going to vary depending on the material that you're using. But in this particular case, where we start with 30 grams and we only have 15 after 8 days, we can determine what A and B both are. So let's do that. So we'll start with, this is part 1, we'll start with our formula. Q is equal to AE to the power of BT. Now, we're told here that we're starting with 30 grams. So in other words, T is equal to 0, and our Q here is going to be equal to 30. So let's put that into our formula. We're going to end up with 30 is equal to AE to the power of B times 0. So e to the power of b times 0. 0 times b is 0, so we end up with e to the power of 0. Anything to the power of 0 is 1. So this part of our equation here will just become 1. So we just end up with 30 is equal to a times 1, which is just a. So now we know what a is. A is just 30. Now the second part of our question, or the information that we're given, is that after 8 days we have 15 grams. So in other words, when T is equal to 8, Q will be equal to 15. So let's put that into our equation. So Q is 15, so we'll have 15 is equal to A, which we now know is 30, e to the power of B times 8. So now we can work out what B is here. The only unknown in this equation is B, so we can isolate B. So first of all, let's bring this 30 over here and divide. So 15 divided by 30 is just 0.5. So we're left with e to the power of 8b on as our power here. Now, because our variable that we're looking for is a power, we're going to get the log of both sides. So let's get the natural log, because we're dealing with e here. So let's get the natural log of both sides. Now, if we do that, what we find is that on the left hand side, I'll just leave that as log 0.5. On the right hand side, we've got the log of e to the power of 8b, and that's just going to be 8b. And the reason for that is because we've got an e down here. What do we need to raise this e to the power of to give us e to the power of 8b? So what do we need to put up here to give us e to the power of 8b? Well, it's obviously just going to be 8b. We've got to put an 8b up here to give us e to the power of 8b here. So our answer here is just 8b. So now I'm just going to divide across by 8. So if we divide across by 8, we end up with log of 0.5 divided by 8, and that gives us a value for b of minus 0.0866. I'll just do it to 4 decimal places. Now, so now we have a here, we now have a over here, and we have b here. So let's just put those into our equation then. So we started with Q is equal to a e to the power of bt. We now know that a is 30 and our b is minus 0.0866. So this is our final equation here. Okay, so let's move on to part 2 then. What were we asked in part 2? In part 2 we were asked how much will be left after 20 days. So how much of this material will be left after 20 days? So let's just write our equation down again. Q is equal to 30e to the power of minus 0.0866t. So after 20 days, what will Q be? So Q will be equal to 30 e to the power of minus 0.0866, and we're talking about 20 days here, so t is 20. So all you got to do is work out everything on the right hand side here, which can be just keyed into your calculator. So we end up with 5.31 grams, rounded to 2 decimal places here. So all of this can be done on your calculator. Fairly straightforward. Okay, so question 3 then was, how long will it take for 1.5 grams to remain? How long will it take for 1.5 grams to remain? So let's have a look at doing that. So this is part 3. We want 1.5 grams to be remaining, so that's going to be our Q. So let's just write down our formula again. So our formula is going to be Q is equal to 30 e to the power of minus 0.0866 t. This is our equation. Now we know that Q is 1.5, so we just write in 1.5 for Q equal to 30 times e to the power of minus 0.0866 t. In this case we don't know what t is. Okay, we have everything else except for t. So first thing I'm going to do is, again, let's get rid of this 30 from the right hand side, so I'm going to divide by 30. So we have 1.5 divided by 30, and that gives me e to the power minus 0.0866 t. Okay, so let's just continue on with that. Actually, I might just do it over here. Now we have our variable here as our power, as part of the power here. So what I'm going to do is get the log of both sides. Again, I get the natural log of both sides, so we're just going to get ln of 1.5 over 30 on the left hand side, and again we're going to get the log of e to the power of minus 0.0866 t. Now on the left hand side we have, you can work this out on your calculator again, so this is just going to become minus 2.9957 to 4 decimal places. And here, because again we've got an e as our base here, what do we have to raise e to the power of to get e to the power minus 0.0866 t? Well, it's just going to be minus 0.0866 t. Divide both sides by minus 0.0866 and we end up with minus 2.9957 divided by minus 0.0866. That gives us a value of t time as 34.59 days. Okay, so it will take 34.59 days for us to have 1.5 grams of this particular material left. Okay, again this is just rounded to 2 decimal places. Okay, so that's the first question. Let's have a look at another one then. This is question 2 here. Okay, so let's look at some sort of a biological material that's growing, okay, like bacteria, okay, and we're going to start with a size of, let's say, p. Okay, the size of the population is p, and it's going to grow at so this is our population size. Okay, population size. Okay, and it's going to grow at a rate of let's say 3%. 3% per day. Okay. So, and we're going to say let f of x, this is our function, that's going to represent the size of the sample. So that's going to be the size of the sample. The size of the sample x days later. Okay, so we have p as our population size. It's going to grow by 3% per day. F of x is going to be a function which represents the size of the sample after x days. Now, The first thing we're going to do here is just have a look down through these, what we can do with this. Let's have a look at the first part here, which is we're going to just ask, what factor of p is multiplied by after a period of 1 day. So we're just going to have a look at 1 day, okay? And we're going to have a look at the factor that p is multiplied by after 1 day. So let's have a look at that. So we want f of x is 1 in this case, okay? And what we're going to do is we're going to say p is what we started with, okay? We're going to start with a population size of p. And what we're going to do is actually add 3% of p, okay? So after 1 day we have the population p plus another 3% of p. So what does that mean? Well, that's going to be p plus 0.03 p. Remember, 3% is 3 over 100. That's just 0.03, and we want to multiply that by p. So after 1 day we have a population p plus we have 0.03 of p. So if we factorize this, take p out, we're just going to end up with 1 plus 0.03. So that's just going to give us p 1.03. P times 1.03. So the size of the sample is multiplied by a factor of 1.03 over a period of 1 day. So after 1 day we can multiply our original population by 1.03, and that will give us our population after 1 day. Okay, so let's just move that on a bit further. So let's have a look at another part then. So let's have a look at 2 days then. Okay, let's have a look at 2 days. So let's have a look at F2. Now that's going to just be, that's just going to be the first day, which is F1, population, the size of the sample after 1 day, plus, well, what we can do here actually, rather than adding, what we can do here is multiply that by 1.03. Okay, whatever the population size is, we just increase it by 3%, which is multiplying it by 1.03. So F1 we know is P 1.03, that's f of 1, and we got to multiply that by 1.03 here. Okay, so that's just going to be P 1.03 squared. 1.03 times 1.03 is 1.03 squared. So this is after 2 days. So what we actually find is, in fact, that f of x is just going to be p times 1.03 to the power of x. So if it's 5 days, x will be 5. If it's 10 days, x will be 10. We just multiply or raise 1.03 to the power of 5 or 10 or whatever the number of days is. So this is our general formula then. Okay, so let's just answer one other question then, and we might leave it at that at this stage. So what I'm going to do now is just look at how long it's going to take for the sample to double in size. So how long will it take for the sample to double in size? Okay, so let's just have a look at that. So really what we want is for f of x, remember f of x represents the size of the sample after x days. So we want the size of the sample to be twice what we started with, so 2p. So f of x then, as we've seen up here, is p times 1.03 to the power of x. So that's our 2p here. That's f of x here. That's what we got up here. Now you can just divide across by p, divide this side by p, divide this side by p, and you end up with 1.03 to the power of x is equal to 2. Okay, so what I'm going to do, I'll just come up here now. So what I'm going to do is just express this in log format. Because our power here is our variable that we're looking for, I'm going to just express this in log format. So in other words, another way of writing this would be the log of get the log of both sides. Log of 1.03 to the power of x is equal to the log of 2. So really actually what I've done here is got the log of the left hand side, log of the right hand side. So let's have a look at that. Bring the x down here, so that's one of the laws of logs. X log 1.03 is equal to the log of 2. So x multiplied by the log of 1.03. All I've done is taken this x here and brought it down here. It's one of our laws of logs. So let's divide across then. So I can isolate x. So x is just going to be equal to the log of 2 over the log of 1.03. Now I can just do all of this right hand side on my calculator, and what I find is that x is just going to be equal to 23.45 days, okay, which is actually 23 days and 11 hours. 23 days and 11 hours. Okay, and that's it. We'll leave it at that, I think, for the moment.